Okay, children. So today we'll do motion kinematics. Some important questions. Ninth important questions we'll do, children. First question is like this, children. If you know, you can tell children, no problem. A scooter starts from rest. Starts from rest means initial velocity is always zero, children. Okay, moves in a straight line with a constant acceleration and covers a distance of 64 meters in 4 seconds. In 4 seconds. This is the question. Question is first one, find the acceleration. Second question, find the final velocity. Okay, initial velocity is zero. Okay, and at what time the scooter had covered half the total distance? At what time it would have covered half total distance? This is a different question. First, let us find acceleration and velocity, children. Yes, children. For acceleration, what formula we will use, children? S is equal to ut plus half at square.
S is equal to ut plus half at square.
64 is equal to 0 into 4 plus half into a into 4 square is 16. 4 square is 16. So 64 is equal to half into a into 16, children. 2 8 is 16, 8 8 is 64. Acceleration is 8 meter per second square. Acceleration is 8 meter per second square. Now once you know acceleration, you can find out final velocity also. What is the formula for acceleration, children? V minus u by t. Don't sit like that, children. Say some answers. V is we have to find out. U is 0 and time is 4, children. So we will go here, children. So V is equal to 32 meters per second. 32 meters per second. Now, children, total distance covered is 64 meters. He is asking 32 meters, means half the distance, will be covered in how much time? Half the distance will be covered in how much time? Of course, it is starting with rest only, children, and acceleration is 8, children. 8. In 32 meters, in how much time it will cover? He is asking. 32 meters in how much time they will cover. So what will do, children?
Sir, S is equal to ut plus half at square.
Ut plus half 8 square. So 32 meters in how much time? So 32 is equal to 0 into t plus half into a into t square. So 32 is equal to 2 4s are 4 into t square. 4 will go down, children. 32 by 4 is how much, children? 8. 8 is equal to t. So t is equal to root 8, children. Root 8 means in 2 root 2 seconds. In 2 root 2 seconds, it will cover half the distance. Okay, children, if you want root 2 is 1.414. 1.414 into 2 is 2.828 seconds. It will cover half the distance. It will cover half the distance. Like this, we should do, children. Okay, children. Next question. Like this one. One more question we'll do. Practice one more question, children. So it's there like this. Second question. Second question, children. So velocity time graph is given, children, like this. Velocity time graph. Velocity time graph. So acceleration, uniform motion. It is retardation. Okay. This is 0, and here it is 4.6 meters per second, children. Here 4.6 meters per second. This is happening in 2 seconds. Uniform motion is happening for 10 seconds. It is coming to rest in 12 seconds, children. It is coming to rest in 12 seconds. What is the motion of lift represented by OA and BC? OA, BC. What is OA, children? OA is called
Acceleration.
Acceleration.
OA is called acceleration. Anyone? What is AB, children? AB?
Sir,
Uniform motion.
velocity.
Uniform velocity. Uniform
Velocity.
speed. Uniform velocity. What is BC, children? Anyone? What is
The
BC?
deacceleration or retardation.
Retardation.
Retardation. Okay, children, retardation. First question. Calculate the acceleration in first 2 seconds. Acceleration. Acceleration from O to A. Acceleration in first 2 seconds. Formula, children, V minus U by T. How much, children? Anyone? V is how much? 4.6. U is how much, children? U is how much?
0, sir.
In how many seconds?
2 seconds.
So 2.3 meters per second square. This is acceleration in first 2 seconds. Acceleration in first 2 seconds. Now, what is the acceleration between A and B, children? Between
0,
A
sir.
and B. Acceleration between A and B, anyone? Acceleration
0,
between
sir.
A and B. 0 because it is uniform speed. In uniform speed, acceleration won't be there. Anyone acceleration in BC children? V minus u by t. What
Sir,
is
minus
V?
2 by 2.3.
What is
minus
V?
2 point
What is V? What is V?
0, sir.
0.
0,
What
sir.
is U?
2. 4, sir.
2
What
2.
is 2? So children answer is minus 4.6 by 2 is minus 2.3 meters per second square. That is retardation children. Sorry, acceleration. It's an acceleration. Retardation means plus. Acceleration means minus. Because it is retardation, no, that's why you got acceleration in minus. Children. Like this you have to do. Children. Next slide. Try to understand children. You should understand. If you don't understand again later it will become difficult for you. Third question children. See children, they have given three graphs children. See here, clearly I am showing here three graphs children. This is 50, this is 100, this is 150, this is 200. So children see here and 0, 1, 2. This is 0 of course, this is 1 of course, this is 2 of course. So first one is, there is a graph A which is going from 0 like this, it is going to. This is A. Another graph is V. It is starting from 100. This is distance time graph. Children. This is distance. This is time. Distance time graph. Okay. Another body is starting at 100 meters, and they both are meeting here. One second. Children. 50 and 2. This is 150 and 2. 150 and 2. These both are meeting like this. Children. This is going like this. This is a graph. Check the graph children, all of you please check the graph. Like this question is also very tough children, you should do again. I'm saying listen here, the distance time graph of two trains. This is train A, this is train B is given. The train starts simultaneously in the same direction. Okay, so how much ahead of A is B when the motion starts? Children, when the motion is starting, how much ahead of A is B? Children, when motion is starting, how much ahead B is from A they are asking when at the beginning of the motion.
Sir, 100. 100 meters.
100 meters. See children, B is starting at 100 meters. B is 100 meters ahead of A. At the starting of the motion, B is 100 meters ahead of A. First question. Second question, what is the speed of B? Speed of B. Speed is equal to distance into time children. Speed is equal to distance into time. So how much is the distance children?
Sir, 100 into 2, sir.
100 into 2.
Sir, 150. 150, sir, distance.
So children, no. What is the question means? What is the speed of B? That's all. Only speed of B. Distance traveled and in how much time children. So children, see here, when it is starting at 100 and it is going to 150. Please see here children. It is starting at 100, it is going to 150. 100 to 150 means how much distance it went children?
50 meters, sir.
50
50
meters.
meters.
In how much time it went?
2 seconds.
2 seconds.
So distance is 50 and time is 2. So 100 meters per second is the speed of B children.
Yes, sir.
100 meters per second. Like this children. Okay. Third question. What, when and where will A catch B? When and where A catches B? When and where A catches B? At what distance
Sir,
they
at
both are?
150 meters and 2 seconds.
150 meters.
At 150 meters they are meeting. At 150 meters they are meeting means A is very fast. A is very fast. So question is, what is the difference between speeds of A and B? No, speed of A, anyone? Speed of A, anyone? Distance into time. So children, it covered 150
Sir,
meters.
300 meters per second.
It
3,
covered
sir.
150. It covered 150 meters in 2 seconds, children. In 2 seconds. So how
So
much?
into 2, sir. 300.
So what is the speed of A? 300. Speed of B is 100.
100.
Okay, children, next one. Is the speed of both the trains uniform or non-uniform? Justify.
Sir, non-uniform.
Uniform. Both of them
Uniform, sir.
individually they are uniform. Individually they are uniform. Straight line, no? This is straight line, this is straight line. So individually they are uniform. Individually they are uniform. No? They are not asking are they both are equal. He's not asking like that. Is this uniform? Straight line, yes. Is this uniform? Straight line, yes. Uniform motion. Both the motions are uniform because they are straight lines. If they are straight lines, it is uniform motion. Understood, children? Children, are you able to understand?
Yes, sir.
Like these questions will come, children. You should not panic. You should do it easily, children. One more variety like this one I will show you, children. One more variety like this one. Question is like this, children. Fourth question. Fourth question. So what is the question? It's time and velocity coordinates are given, children. Time and velocity coordinates. Children, this is time. This is v. Velocity. Okay, this is in seconds. This is in meters per second. This is in seconds. What are the coordinates means? 0 to 1 4 2 6 3 8 4 10 5 12 6 14. Like these coordinates they have given to you. An object is moving along straight line with uniform acceleration. The following table gives the velocity of an object at various instances of time. Now questions on this, children. Questions on this. First question, anyone? Plot the VT graph. Children, you have to draw the graph. You know how to draw the graph now, children? You have to draw, they won't give graph paper, children. You have to plot on your own. 0, 1, 2, 3, 4, 5, 6, 7, like that. Here, children. Each block is 2, 4, 6, 8, 10, 12. First one is 0, 2, children. First one. 0, 2 means here it will be. Second one is 1, 4, children. 1, 4 means here. Third one is 2, 6. Here, children. The fourth one is 3, 8. 3, 8 means here. Next 4, 10, children. Next 5, 12. Next 6, 14. So like these it is coming, children. This is the graph. This is the graph. Second question, children. Calculate the, find the velocity of object at the end of 2.5 seconds. Velocity at the end of 2.5 seconds. Formula is, so children, formula. Velocity at the end of 2.5 seconds, children. So from this one we will find out if you want. See, children, 2.5 means here it will come, children. So you have to, okay, if it becomes difficult because children graph paper means nicely you can say at 2.5 what is there. First let's find acceleration. What is the acceleration, children, here? Anyone? V minus u by t. Okay, children, acceleration is v minus u by t. Yes, children, acceleration is, yeah, final between this, because it is uniform acceleration, he only said, between these both cases we will find acceleration. 4 minus 2 by 1 minus 0, that is 2 by 1, that is 2 meters per second square is the acceleration. Acceleration is uniform acceleration, children. Now velocity at the end of 2.5 seconds. What is the formula we will use? Anyone? What is the? Huh? Very good. U plus A.
U plus 80.
U is how much, children? U is how much? U is how much? 2.
2, sir.
Plus acceleration is how much? 2.
2.
After how many seconds? 2.5 seconds.
2, sir. 2.5.
2.5, children. So how much it will be, children? 2 plus 5, that is
7 meters per second.
very good. 7
7
meters per
point.
second. After 2.5 seconds, the velocity is 7 meters per second. After 2.5 seconds, the velocity is 7 meters per second. You should know, children, you should do like this sums. Like this sums, if you do only, you become very strong. Small sums I will do, and I will enjoy when it is not acceptable, children. See here, next sum. In this only, next question. Calculate the acceleration. Acceleration we found out. Calculate distance covered in last 4 seconds. Distance in last 4 seconds. Children, what is the distance in last 4 seconds? Means last 4 seconds means, children, 10, 8 to 40. 8 to 12, sorry. 10 to 40. Yes, children. Acceleration is how much, children? Anyone?
2 meters per second.
Initial
2,
velocity.
sir.
Initial velocity.
2, sir.
Initial velocity 2.
2, sir.
He is asking last 4 seconds.
4
Children,
seconds, sir.
so the last 4 seconds means try to understand. Initial velocity will become when 10 the velocity is 4. When 10 the velocity is 4, so initial velocity, sorry, initial velocity will become 4, children. Try to understand, children. When 10 the initial velocity is 4. Last 4 seconds means from here to here they are asking distance, children. From here to here. So how to find out, children? S is equal to ut plus half ut square. Okay, children, u is how much, children? 4,
4.
4, half, 2, 4 square. 16 plus 16, 32 meters. If you want, I will show you one more method also, children. I told you many times, children, area of VT graph gives you displacement. Do you remember, children? Like that also, if you want, I will show you, children. Like
Yes,
that also,
sir.
I will show you. Like that also, I will show you, children, so that you'll feel comfortable. 6 to 14. 6 to 14. Okay. So, last 4 seconds, this is my children. We get wrong, children. Everything we get wrong. I took this as time, children. I took this as speed. I did wrong, children. I'm sorry. I did wrong. Nobody is telling also. Means you are not able to understand anything in the class. I understood. Last 4 seconds means from 2 to 6 seconds. Acceleration is 2 only. Last 4 seconds he asked. So when 2 seconds is there, what is the speed? 6 meters per second. 6 meters per second. Initial velocity. When 2 is there, 6. Now fine, children. Nobody is saying, children. Happily you are sitting at and telling for
Sir,
my sake.
Sir, I
Please,
thought to ask, sir, but when you wrote for it, I
you should
just had a
ask
little doubt.
6 into 4 plus half into 2 into t square is 4 square. Okay. So children, 2 to 1, 6 4 is 24 plus 16. How much, children? 40 meters. This is by formula, children. Geometrically also I will show you, children. Geometrically means last 4 seconds will come from when to when, children? Last 4 seconds. Last 4 seconds. 3 to 6. No?
3 into
Then why I took 3 means 8, no? 3 means 8, no? I am taking wrong way. No one is saying, children. That is my problem. 3 is 8. 3 is 8. Okay, geometrically we'll see. 6 is 14. 6 is 14, children. What is the shape, children? Anyone? What is the shape?
Trapezium.
Trapezium. Area of trapezium
trapezium.
formula? Area of trapezium?
Half h into a plus
Ha,
Half h into a plus
A plus
b.
B.
Half h into a plus b, children. Yeah. Tell me, children. H is how much? 4 seconds.
4.
4 seconds.
Here how much? Here it is 8.
8,
And here how much it is? 14.
12,
14. 14.
14. 14.
Okay, children. So how much is coming? 2 into 22. That is 44 meters is coming. Why we got wrong answer? Can anyone tell? Why we got wrong answer? Because we have to take 8 meters per second as initial velocity. 8. Then you will get correct. 8 we should take. 8. 8 4s are 32. 32 plus 16. Am I correct? Why we are getting wrong answer in this case? Yes.
Sir,
Anyone?
then we'll get 48, sir.
Why we are getting wrong answer? First, 1, 2, 3. Last 4 seconds was right. So right. 1, 2, 3, 4. I'm sorry. I'm sorry. I'm also getting confused. I'm also getting confused. From 2 only we should take. From 2 only we should take. This is correct. This is correct. 3, 4, 32, 48. Here we went wrong. Here. What is the 2 to 6 only 4 seconds? So 2 to 6 is 4 seconds. 1, 2, 3, 4, 4 seconds. No. So What is the height we should take? 4 seconds, correct only. But here, how much children? Here it is 6.
6
We should
here.
6 here. Now tell me children, how much? Half h into a plus b. So half h 2 into, now to going more or less 40 only we are getting. Where we are going wrong? Anyone can tell where we are going wrong? Yes, sir, where we are going wrong? When initial velocity I took 6 only, no? Initial velocity I should take 6. 6 goes 24. 24 plus 16, 40. See children, both correct. 40 meters, 40 meters. Now correct, because children, initial velocity when it is 2, it is 6 children. I know you people don't understand, when neither you are interested also, but my fate I am saying children, that's all. Approximately nothing else is there. You won't get doubts, you won't get any ideas, you won't get any answers, nothing. Correct time you will join, that's all. Except that you can't do anything. Fifth question. So fifth question is there like this: time and distance. This time they give time and distance. Okay. So what is the time? It's at 11 o'clock. It was 0. Distance is at 11 o'clock. It is 0. And at 11:30, 30 meters they covered. 30 kilometers they covered. At 12 o'clock, they covered same 30 only. I mean 30 only. And at 12:30, they are at 65 kilometers, and at 1 o'clock they are at 100 kilometers. These are the distances and times they have given children. This is in hours, this is in kilometers. So first question, children, plot the distance time graph. Plot the distance time graph. This is 11, 11:30, 12, 12:30, 1. Okay children, the distance is 10, 20, 30, 40, 50, 60, 100 also is given. At 11 o'clock it is at 0 children. At 11 o'clock it is at 0. At 11:30 it is at 30. At 12 also it is at 30. At 12:30 it is at 65. 65. At 1 o'clock it is 100. So it is going like this, like this, like this, and 100 means somewhat like this, 100 means. This is the distance time graph they have given. Second question. Find the speed of the car between 12 and 12:30. Anyone? Between 12 and 12:30, what is the speed of car? Speed is equal to between 12 and 12:30. Children, at 12 it is 30, and at 12:30 it is at 65 kilometers. So how much distance they cover, children? 65 minus 30. Distance. The speed is equal to distance into time, children. Speed is equal to distance into time. But since accelerated motion, we can't use distance into time, children. We can't use distance into time. So what we will use means, okay, how much distance it covered, children? From 65 to 30, how much distance? Anyone? 65 to 30, how much distance?
35.
35 kilometers. Okay, and time, how much, children, it is?
Sir, 30 minutes.
30 minutes. Time is 30 minutes. So, since if it goes like that, it's uniform motion only, children. So speed is equal to what we will use, children, formula? Distance into time, because this is uniform motion. Like this means uniform motion. For uniform motions only we should use like this. So distance is how much? 35 kilometers. And time is how much, children? 30 minutes. Minutes to hours by 60. Minutes to hours by 60. So 35 by 2 is 17.5 km/h is the speed between 12 to 12:30. 17.5 km/h is the speed between 12 to 12:30. Can anyone say what is the speed between 11:30 and 12 o'clock? Yes. What is the speed between 11:30 and 12 o'clock? Anyone?
30. 30.
Huh?
30. 30.
Sir, 0.
0 is the answer. Because at 11:30 also it is at 30 kilometers. At 12 o'clock also it is 30 means it is at rest. It is not moving. Here it is not moving. So it is at rest. Body is at rest. No speed. Body is at rest. It is not moving. 30 kilometers, 30 kilometers means it is not moving. You should understand like that. Next question. Find the average speed of the car. Average speed. What is the formula, children? Total distance by total time. Total distance by total time. What is the total distance covered, children? 100 kilometers. In total time, how much, children? 11 to 1, how many hours? 11 to 12, 12 to 1, 2 hours. So answer is 50 kmph. 50 kmph is the average speed, children. Is the car's motion an example of uniform motion justified? Is it uniform motion, children? It is covering equal distances in equal intervals of time. No, but in the middle it was rest. That's why, as in the middle it is a rest, it is not uniform motion because it is covering, but here it came rest again it is going. So uniform motion, rest and uniform motion was there, children. So it is not an example of uniform motion because in the middle sometimes it was at rest also. Next question. Next question. Sure. Name the quantity which is measured by the area occupied by the VT graph. What is area of VT graph gives anyone?
Sir, distance.
Displacement. Area of VT graph gives displacement. I told you many times, children, try to remember. Area of VT graph gives displacement. An object is moving in certain direction with acceleration in the perpendicular direction. Children, what is this? An object is moving in certain direction with acceleration in the perpendicular direction. What is it called? An object is moving in certain direction with acceleration in a perpendicular directions. Yes, children, what is it called? An object is moving in certain direction with acceleration, but in perpendicular direction, going up or coming down. Free falling body or upward thrown bodies, children. It is freely falling body or upward thrown bodies, children. Next, under what condition is the magnitude of average velocity of an object is equal to average speed? Anyone? When will the average velocity and average speed will be equal? Anyone? When will the average speed and average velocity will be equal? Anyone? Yes,
Sir, when there is a linear motion.
very good. In straight line motion, when a body is going in straight line, distance and displacement are equal. When a body is going in straight line, distance and displacement are not equal. So in a straight line motion, average velocity and average speed is same. Next question. Give an example of uniform acceleration motion. Uniform accelerated motion. Anyone? I want a best example for uniform accelerated motion. Anyone? I want a best example for uniformly accelerated motion.
Sir, rocket launch is in a no uniform accelerate, sir.
No, but after going into space, it comes to go with constant speed.
Sir, pendulum.
No.
Car moving in speed.
The best example in uniform accelerated motion, always remember, children, body moving in a circle. Body moving in circular motion is uniform acceleration motion because continuously it is changing its direction. Because it is changing its direction, velocity also changes. Velocity changing means acceleration. Why means it continuously changes its direction. If direction is changing, velocity also changes. If velocity changes, accelerated motion. If it is an accelerated motion, uniform accelerated motion. The best example on that is a body moving in a circle. Because continuously it is changing what? Direction. If direction is changing, velocity changing. If velocity is changing, it is said to be acceleration. Very important. Okay. A body moving in a circular path of radius r. Right, understood? A body is moving in circular path of radius r. Okay. What will be the distance and displacement when it completes half rotation? After completing half rotation, what is the distance and displacement? What is the distance, anyone? Yeah.
Pi r.
2 pi
Pi
r by
r.
2 pi r, only pi r. 2 pi r is full. Anyone displacement? Anyone displacement? Anyone displacement?
2R.
Sir,
Yes.
2R.
Very good.
Plus
2 r.
2r.
Just 2 r. This is r. This is r. R plus r is 2 r because it is the shortest distance between initial and final points. It's the shortest distance between initial and final points. I told you already. Next question. Like these questions, if you don't, you become strong children, but you people are not at all telling any answers. Just sitting like that. Only 2-3 students are telling very continuously. That's all. A train starting from west picks up a speed of 10 meters per second. Picks up a speed of 10 meters per second in 100 seconds. It continues to move at the same speed for the next 250 seconds. So for 250 seconds, same 10 meters per second it will go for 250 seconds. Okay. Then it is brought then to rest. Then it is brought to rest in next 50 seconds. In next 50 seconds. Find the speed, then first draw the graph they are asking. First draw the graph. Okay, children, what is the question? Train starting to picks up a speed of 10 meters per second. So this is 10 meters per second, children. This is 10 meters per second. In how many seconds I said? 100 seconds. In 100 seconds. Next 250 seconds. Next 250 seconds. Next 250. 100 plus 250 how much, children? 350. It is with same speed it is going. It is with same speed it is going. In the next 50 seconds it comes to rest. Next 50 seconds it comes to rest. This is the graph, children. Now question on this. What is the acceleration from O to A? Yes, children, anyone? It is attaining 10 in 100. How much, children? 10 by 100? 0.1 meter per second square. Yes, acceleration from A to B, anyone? Acceleration from A to B, anyone? Acceleration from A to B, anyone?
0, sir.
0. Acceleration from B to C. Final
Minus
velocity is
0.1.
0.
Minus
Initial
0.
velocity is 10 by 50. So minus 1 by 5, that is minus 0.2 meters per second square. This is acceleration is minus, but retardation is 0.2. Retardation is 0.2. Acceleration we got minus, but retardation is 0.2. Like this questions will be there, children. So you have to practice, children. If you practice, then you will become strong, children. So the two graphs are given like this. See here. Two graphs are given like this. One graph is like this. One graph is like this. Okay. This is speed time graph. Velocity time graph. This is also velocity time graph. And here velocity is 20. 20 meters per second. And 1, 2, 3, 4. 1, 2, 3, 4. And this is also velocity time graph, children. This is 20. This is 10. And up is 30. This is occurring in 1, 2, somewhere 3, 4, 5. Like this, they are doing two graphs. Okay, children. First one. What is the use of odometer in the vehicles? Anyone? What is the use of odometer? What is the use of odometer in the vehicles? Anyone? It tells about
The distance.
The total distance traveled.
total distance traveled. Two graphs A and B are shown in the motion here. State how the speed is changing with time for both the bodies. State how speed is changing. Here, what is the speed, children? What is the speed?
0, sir.
What is it? No, it is uniform speed. Who told 0? It is uniform speed, 20 only. In graph A, it is uniform speed. It is going at the same speed. What is the speed? 20. With 20 meters per second only continuously it is going. And in the case of B, first it is acceleration, then it is retardation,
Retardation.
then again it is,
Retardation,
Acceleration.
acceleration.
so it is non-uniform speed. Non-uniform speed. You should know, children, all these things. This is uniform speed because at 20 only, here also 20, here also 20, here also 20. It is going with uniform speed, children. You should know what is uniform speed. Then only you will understand, children. Okay, children, so I told you so many numericals.